This video will introduce FMU models and their use in 3D experience. We will get into 4 parts. First, a general presentation of FMU models will be given. Then, we will see the prerequisites of the FMU development environment. The structure of a FMU model will then be introduced. Finally, we will see how to import a FMU model into 3D experience. Let's get into a general presentation of the FMI. FMI means Functional Mockup Interface and is a standard to exchange dynamic model as FMU files. FMU are functional mockup units. They are composed of a zip file containing XML files, binaries and C code. FMU are compatible with many simulation softwares. They can be created by exporting a model of a compatible software. They can also be created from scratch with C++ code. So it is possible to reproduce any behavior, in particular, interfacing the outside of the 3D experience. Basically, a FMU is a block with inputs and outputs. Inside the block, a behavior is encoded. The user can't know what is the behavior or how it has been developed. Now, let's set the FMU development environment. The Visual Studio 2022 Community Edition IDE can be used. Go to the project's properties. Platform is x64. Project will be compiled using Visual Studio 2012 Platform toolset. In linker, input, the additional dependencies should appear. Try to rebuild the project. Rebuilding the project updates the FMU file if rebuild succeeded. If the rebuild fails, it means that something is wrong, whether in the code or in the project settings. The structure of a FMU is composed of several files. Only 2 of them will be modified, model description.xml and FMI component.cpp. The other files contains the translation of the C++ code to a FMU file. Let's check the model description.xml file. It contains a description of the FMU file that will be created. First, general information is given. Then, the units that will be applied to the inputs and outputs are defined. Types are then defined. A type combines a unit and other information such as the range in which a variable must be. Units and types are optional, but they can help the user to know what unit is expected as input and what unit is used for an output of the FMU block. Now, inputs of the FMU block are defined. Inputs have a name and a value reference that must be unique. Value references must be a number between 0 and n-1, if n is the number of inputs plus outputs. A type is affected to each input. Outputs of the FMU block are defined like the inputs. Lastly, the value references of all the outputs must be in the model structure, in both outputs and initial unknowns. Now, let's move on to the other interesting file, FMI component.cpp. This file contains the behavior of the FMU. It is composed of several parts. First, the library's imports. Then, the global variables declaration. Then, 2 FMI functions are defined. The first one gets the values of the inputs of the FMU block. The other one sets the values of the outputs of the FMU block. When the FMU is running, the following functions are executed. 2 of them are important and will be modified. The first one is init, which is executed once at start. The other one is compute step, which is executed at each step. So this is where the FMU behavior is. Defining global variables is important as every variables defined in compute step will be erased at the end of a step. Let's import a FMU into 3D experience. Launch the Functional and Logical Design app. The 3D experience client must be in English to run FMU models, otherwise an error will occur when running a FMU model. For that, click on the user's picture. Then, Click on the arrow next to Preferences, then Customize. In the Options tab, set the user interface language to English. Close the window and restart the 3D Experience client. If the background is blue, change it to a white background. For that, right-click on the background and change the ambience to white design for instance. Right-click on Logical. Insert new logical component. Select Logical Reference. Right-click on the logical block created and do the same to create another block inside. Select the new block and import a FMU inside. Inputs and outputs appeared on the FMU block. The FMU block is now imported. Let's summarize what we have learnt during this video. First, we learnt the basics of a FMU, what is a FMU and why we will be using it. Then, we saw the prerequisites to develop a FMU from scratch using Visual Studio. Then, we saw the internal structure of a FMU and how to describe a behavior with XML and CPP files. Finally, we saw how to import a FMU file into 3D Experience.